Hello and welcome to Algebra 2. Today is Thursday, October the 8th, and our topic for today is simplifying rationals. Okay, before we really get started, a rational function is literally just a function that is a fraction. Think rational like ratio, right? It literally has the word ratio in it. Ratio is just another way to say fraction. So we're saying a function that has a ratio, just a function that has a numerator and a denominator. Okay. Our guiding principle today is that we can cancel numbers when they're being multiplied, but not when they're being added. So we can see this and we can see, okay, great, cancel, I get 4. Another way to prove that is if we multiply 4 times 3, we get 12 over 3. It's also 4. So canceling with multiplication works. But if I try to cancel these, that is not a true statement because 4 plus 3 is 7, and 7/3 is 2 and 1/3, nowhere near 4. So we can cancel when things are being multiplied, but we can't cancel when things are being added. Okay, let's dive into our first example. Always remember to pause and write the original example. Our instructions here are simplify and state excluded values. An excluded value, it's just a value that makes the denominator 0 because we cannot divide by 0. 1 over 0 or anything over 0 is undefined. Okay, so let's look at this guy here. Well, I definitely want to factor this numerator before I can see what's going to cancel. So 10 and 13 don't have anything in common, but x squared and x do. So I can take out a single x, and now I've got 10x minus 13 over 4x. Okay, everything's being multiplied, so I'm good to cancel. So I can cancel this x with this x, and we're left with 10x minus 13 over 4 is our final simplified version. In this case, there are no excluded values because nothing can make the denominator 0. The denominator is 4, so in this case, there are no excluded values. Let's pause and write this. We're going to say excluded values make the denominator 0. So it's just one little extra step at the end there. Make the denominator 0. Pause whenever you need. Okay, example 2, make sure you write the original problem. Great, same instructions, I want to simplify. So let's start by factoring this guy. Your first step is always factor, because when things are broken down into factors, then you're really able to simplify. Right now, everything's being added or subtracted. So I'm going to factor this guy. I get negative 12 and 1. How about positive 4 and negative 3? I don't need to make a box here because there's an assumed 1 up front. No number in front of x squared, we don't need a box. So for this, I get x plus 4 and x minus 3. Color code. Great. The things in yellow, these are the same things, right? When we factor it, it's still the same expression. Okay, how about this guy here? This looks like a difference of squares because I have only two terms and a perfect square. So the square root of x squared is x, square root of 16 is 4, and I get x plus 4, x minus 4. If you're feeling shaky on your factoring, we've got to be really good at it. Please reach out to me for tutoring as soon as possible. Okay, now we're just going to plug these guys back in. Yellow with yellow, blue with blue. I've got x plus 4, x minus 3, over x plus 4, x minus 4. Great. The x plus 4s will cancel, and then we're just left with x minus 3 over x minus 4 is our final answer. Excluded values, what makes the denominator 0? We're going to say x equals 4 is excluded. Okay, let's do another one. Example 3. So remember, what we're really doing here is factoring, then canceling. So our numerator has nothing to factor, but I can factor this. This also looks like a difference of squares because I have two terms and a perfect square. The square root of x squared is x. The square root of 4 is 2. So I get x plus 2, x minus 2. Yellow with yellow, let's plug it back in. Remember, they're the same expression. Now I have 2, x minus 2. Okay, the x plus 2's will cancel. But what's going to happen when nothing's left up top? It is just a 1. Not a 0, but a 1. This is our final answer. Excluded values, what makes the denominator 0? X equals 2 is excluded. Okay, we got one more example. All right, a tough one. Lots of factoring here. So when you're not sure what to do, always factor first. So let's factor our numerator. I've got negative 30, negative 7. How about 15 and 2? Nope, 10 and 3. Negative 10 and positive 3. We do not need a box because there's no number up front. So I've got v minus 10 and v plus 3. Okay, let's factor our denominator now. I've got negative 24 and negative 5. Let's try negative 8 and positive 3. Guys, if you're stuck here, make a factor tree. Just keep going until you find something that works. Okay, so I get v minus 8 and v plus 3. Okay, we're just going to go and plug these guys back in now. So I have v minus 10, v plus 3, over v minus 8, v plus 3. Nice and neat, v plus 3's will cancel, and we're left with v minus 10 over v minus 8. Now, you can keep the parentheses if you want. You don't have to. It won't change anything at this point. Okay, so this is our final answer because there's nothing left to simplify. Let's do excluded values. I'm going to set v minus 8 equals 0. So v equals 8 is excluded. Okay, that's all for today, guys. Thanks.